Uh, Good afternoon, my student. Welcome to chemistry lesson. And today I'm going to talk about enthalpy changes. And today I'm going to be specific on heat of a reaction. That is determination of heat of a reaction. And especially a reaction between a base and an acid, what we refer to as a neutralization reaction. So at the end of the reaction between the base and an acid, eventually neutralization reaction takes place. So in a KCSE exam, especially question 2, you may come across the same determination of enthalpy changes. So in fact, in this experiment, I'm going to use a KCSE sample question to determine the heat of a reaction. Is it okay? So in 1 minute, let me take you through the chemical reagents I have. Then we look straight away at a sample question. Is it okay? So with me here I have the following reagent, and please, I'm going to take only 15 minutes, then the lesson is over. So concentration is very important. So I have this solution. I have these two solutions here. The first solution is solution Y. You can see the label. Then this solution Y is 1 molar dilute nitric 5 acid. Is it okay? Then the next solution is solution Z. You can see the label. Then this solution Z is 1 molar sodium hydroxide solution. 1 molar sodium hydroxide solution. So we are going to react these two solutions, solution Y and Z. Then of course, apparatus are very important in this lesson. So whenever you talk of enthalpy changes, always you have to use a thermometer. This is a thermometer that measures a maximum of 100 degrees Celsius. So it is very important also. Then I have a plastic beaker, and this plastic beaker is 100 mils. Then I have other beakers, glass beakers, which are each one of them is 100 mils. Then I have a measuring cylinder. This is also very important. It is 100 mils, made of glass. Then I have the burette. Some students normally believe that a burette is only used in titration experiment. No, even in enthalpy changes, it is normally used to measure accurate volumes. Then I have the funnel, which will enable me to fill the burette with these solutions. Is it okay? So let me, in 1 minute, show you a sample question. We go through it. Is it okay, my student? And please, your concentration is very important. So let us read the question, my student. You are provided with solution Y, which is 1 molar nitric 5 acid, and solution Z, which is 1 molar sodium hydroxide solution. Then we ask ourselves, what are we expected to do in this question? So look, you are required to determine the heat of reaction per moles of solution Y using the procedure below. So I'm going to give you the procedure in this question, my student. Is it okay? But after the procedure, you have a table to complete. So in this case, you have this table where you have volume of solution Y used in centimeter cube. Then we have temperature obtained in degrees Celsius. So what are we going to do here? We are going to react these two solutions, solution Y and solution Z. But solution Y, you have been told, is in the burette. we are going to fill the burette with solution Y in the procedure, and the volume of solution Z that will be used in this case will be constant. We are going to measure only 20 mils of Z. Then we shall be adding a volume of solution Y at an interval of 4 mils, 4 mils, 4 mils. And every addition of those 4 mils of solution Y will take the highest temperature reached. Look, for example, if I'll add 4 mils of Y to solution Z, I'll have to reach the highest temperature reached. Then I again add 4 to make it 8. I take the highest temperature reached. Then I also add 4 to make it 12. Then I take the highest temperature reached. Then I again add 4 to 16 plus 4 20 plus 4 24 plus 20 plus 4 28 plus 4 32. Is it okay? Then I record the highest temperature reached after every addition of 4 mils of solution Y to solution Z. Let me now take you through the procedure. And I'm too fast, my student. If you are not very keen, you may not get. So be very keen and concentrate. So procedure number 1, I'm going to take solution Y. Then I fill the burette. That's procedure number 1. I fill the burette with solution Y. Is it okay? Is it okay? So let me transfer this solution Y into a glass beaker like this. Then I transfer this solution into the burette. Let us fill the burette, my student. Then please focus. I'm using the funnel to fill the burette very fast. That is good. So look, when you fill the burette, ensure it is at the 0 mark, and always remember to read below the lower meniscus. Is it okay? So I fill the burette. That's procedure number 1. Then let us now look at procedure number 2. So procedure number 2, I'm taking solution Z, which is the base sodium hydroxide solution. Then I measure 20 mils of this solution Z, the base, using a measuring cylinder. Is it okay? Let us go. So I have measured 20 mils of solution Z, the base sodium hydroxide. Then the next procedure, I transfer this solution Z into a clean plastic beaker like this. Let us go. Like that. Then after that, my student, I have now to take a thermometer. I have several thermometers, but let me use this one. Then I dip this thermometer into this solution Z in the plastic beaker. Then I have to take its initial temperature. This is 17.5 degrees Celsius. 17.5 degrees Celsius. Then this is now very important, my student. So I need to run this solution Y in the burette, 4 mils from the burette into this solution Z. Then after that, I have to read the highest temperature reached. Remember, this is a base and this is what? An acid. Is it okay? So let me now take 4 mils. Let me now take 4 mils from the burette. So I have to run from 0 up to 4. Is it okay? From 0 up to 4. Let us go. And this one you must be very keen. That is exactly 4. Is it okay? Then just focus slowly. Then I have to start using a thermometer and read the highest temperature reached and read the highest temperature reached. So you have to give it time. And this is now why I normally say that patience is very important until the highest temperature is reached. And please don't make a mistake of removing the thermometer from this solution. That is wrong. The thermometer must remain in this solution until all the experiments are over. Is it okay, my student? Thank you. So the highest temperature reached here is, that is 19.0. From 17.5 it has come to 19.0. 19.0. So to ensure that this thermometer stays in this solution, let me put it inside this beaker so that the beaker will help me to ensure that the thermometer remains in the solution. Is it okay? Let us now complete the table slowly by slowly, please. So my students, I found that when I add 4 meals of Y, the highest temperature reached is 19.0. This is 19.0 degrees Celsius. 19.0 degrees Celsius. Then I have now to add again 4 meals of Y to the mixture. I have to add 4 meals again of solution Y from the burette to the mixture. Then I again take the highest temperature reached. Let us go. Let us go. So I have again to take the highest temperature reached. And remember, I've said let the thermometer remain in the solution. Let us go. Now from 4 I move to 8. To add 4 means I move to 8. That is 7. That is exactly 8. It means I've added 4 meals of Y to the mixture. Again, after addition, I have to start using the thermometer. And I said the thermometer must remain in the solution. Don't remove. And read the highest temperature. So you start using a thermometer into the mixture as you read the highest temperature reached. The highest temperature reached for this one is 20.5. Exactly 20.5 degrees Celsius. Then I have again to record. So this is 20.5 degrees Celsius. 20.5 degrees Celsius. Then again I again add 4. I again add 4 mils of solution Y from the burette to this mixture without removing the thermometer. Please. Let us go. I'm again adding 4. I'm again adding 4 mils. I'm again adding 4 mils. So from 8 we move to 12. Like that. That is 12. And as I add, I have to start the mixture using the thermometer. And again read the highest temperature reached after every addition. that is 21. 21.5. 21.5. Hope you are focusing, my student, isn't it? Hope you are focusing. That is 25.5. That's the highest temperature reached. Then I have again to record in the table. So after adding 4 again, I'm getting 21.5 degrees Celsius. And I add again 4 to 16. Then again take the highest temperature reached. So focus slowly again, my student. So I have again to add 4 means from the burette of solution 1. Let us go. Then from 12 I move to 16. I'm adding 4. That is 14, 15, 16. Then I again start using the thermometer and record the highest temperature reached. And remember, the thermometer should not be removed from the solution. Don't remove the thermometer. Let the thermometer remain in the solution. It's still moving, still increasing, it's increasing. That is 22 again 0.5, 22.5. The temperature remains at 22.5 degrees Celsius. 22.5 degrees Celsius. So I have also to record like this. 22.5 degrees Celsius. Then my student, after recording, I again add 4 mils of wine to make it 20. Is it okay? Let us go. I'm adding again 4. Now from 16 I move to 20. I add up to 20. That is 20. Then I again read the highest temperature reached. I start first of all using the thermometer without removing. Then I read the highest temperature reached. That is 23.5. Yeah, 23. It remains at 23.5. So I have to record very fast. 23.5 degrees Celsius. Then I again add 4 to the mixture to make it 24. Is it okay? Let us go. I again add 4 mils without removing the thermometer from the mixture. Let us go. Now it is up to 24. From 20 I add up to 24. Exactly 24. Then I have to read. I start first of all using the thermometer. It is dropping. It has started dropping. It has started now dropping. Oh, it is now dropping. It has dropped to 3.0. It has dropped to 3.0, my student. 23.0. So it has dropped to 23.0. It has dropped to 23.0. Are you getting? Now the temperature has now started reducing. Let me add now again students, just a minute. From now 24, I add again 4 to 28. I add solution Y, 4 minutes again from the burette. Now to 28, to the same mixture without removing the thermometer. Now from 24, I'm adding up to 28, the mixture. 28. So I've added 4 to make it 28 from 24. Then I again start using the thermometer. And this one, my student, requires patience, as you can see. If you are not patient, you cannot make it. You cannot. Oh, it is still dropping. It has dropped to it has stopped at 21. It has dropped to 21. So I have to record 21.0. 21.0. It has dropped to 21.0. Then my student, finally I have now to add again 4 to 28 to make it 32. Is it okay? Let us continue the last one. So I have to add again 4. Then now from 28 I move to 32. Is it okay? Let us move together, please, slow by slow. Let us go. 29, 30, 31, 32. Then I again take the highest temperature reached. My student, you can focus and see what I'm doing. This is what you'll also be doing in an exam. Don't tense. Okay. It is now at 19. It's now at 19.0. 19.0. It has dropped to 19.0. And it has stopped there. It is no longer dropping. So I have also to record the same, the table, my student. So what my students have to record here, 19.0. 19.0. 19.0. So my students, here we normally look at complete table will earn you a mark. Just when you complete this table, there is a mark. Then there is something also called trend. Trend is T. When you look at the trend, when you are very keen, the trend of the temperature has been from 19, 20.5, 21.5, 22.5, 23.5, then 23.0. So it has been increasing, then all of a sudden the temperature again start dropping. Are you getting? So that's the trend. That one will also earn you another mark. Is it okay? Then we have another mark for what we call decimal place. Decimal place, you will also get 1 mark. What about the decimal place? When you look at the values of the temperature, it is either 19.0 or 19.5. So in this case, I've been using one decimal place. So let the decimal place be uniform. And also remember, for the temperature reading, it's either 0.0 or 0.5. 0.0 or 0.5. That one you already know, my student, and I don't want to talk about it. Is it okay? Thank you. So the trend and whatever, then those are the marks that you are going to earn from completing this table. Is it okay? Then let us now focus on a very important section, questions. Let us now focus on a very important section, that's the questions. Question 1 or question A. Is it visible? Is it visible? Good. Then you have been told, plot a graph of highest temperature against volume of solution Y using. You plot a graph of highest temperature against volume of solution Y using. So my student, in 1 minute, I'm going to plot a graph. So you can just focus and see. So this volume of solution Y will be on the Y-axis. Is it okay? Then this is the highest temperature reached will be on the Y-axis. So volume of solution Y will be on the X-axis, while temperature will be on what? This is X-axis, volume of solution Y. Then temperature will be on Y-axis. Is it okay? So let us now focus. Let us now focus, my student. Let us now focus here. Let us now focus here. And I need some light, isn't it? Let me. Is it clear? If it is clear, it is okay. So I'm going to use, so this is a graph. This is a graph that this is a graph paper which will also be given in that exam. Is it okay? So here I'll have to write volume of solution Y in a centimeter cube. Is it okay? That's on the X-axis. So I take this one to be my X-axis, then I take this one to be my Y-axis. Then here I have to write the temperature. So I'll have to write the temperature here. Let me say the highest temperature. Highest temperature in degrees Celsius. This is a graph of highest temperature in degrees Celsius against volume of solution Y in centimeter cube. Is it okay? And when I look at the values for the volume of solution Y used, the highest volume is 32. Is it okay? So when I'm choosing my scale, I can assume this is 0, the origin is 0. Is it okay? Then I take one smaller square box. I take one smaller square box to represent 1 centimeter cube for this volume of solution Y. So that you can say this is 5, this is 10, this is 15, this is 20, this is 25, this is 30, this is 30, then this is 35, then I say that is 40. Is it okay? That's the base scale for the X-axis. Then when I look at on the Y-axis, the highest temperature reached is 23.5. So a suitable scale, in this case, on the Y-axis, I again take one small square box to represent 1 degree Celsius. Is it okay? So that I can also say this is 5 degrees Celsius, 10, 15, 20, 25, 30, 35, 40. Is it okay, my student? So I'm going to plot, and for example, when the volume of solution Y is 4, the highest temperature reached according to our table for the temperature is 19. So I just stand where there is 4 on the volume, then I move up on y-axis up to 19. So if this is 20, 21, 22, 23, 24, 25, 26, 27, 28, 29. So 29, so I use a cross, that is 19. Let me do it properly. If volume is 4, then the temperature is 19. The temperature is 19. That is from 15, 16, 17, 18, 19. Is it okay? Then when the volume is 8, this is 6, 7, 8. Then the highest temperature is 20.5. So I have to move up to 20 on the y-axis. This is 20. Then it is 20.5. So 20.5 is it at the center of this box. Is it okay, my student? Then when the volume is 12, when the volume is 12, 1, that is 10, 11, 12, then the highest temperature is 21.5. So I move up 21.5. So if this is 20, this 21.5 is at the center of that box. Is it okay? Then when the volume is 16, this is 15, 16, then the temperature is 22.5. So I move up to 20, then 22, that is 21, 22, then 0.5 at the center of that box like that. Is it okay, my student? Then when the volume of Y is 20, that is 20, then on the y-axis the highest temperature is 23.5. So I move up to 20, then 23, 1, 2, 3, 20, then 3, 20, 21, 22, 23, then 0.5 somewhere there at the center of that box. Is it okay, my student? Then when the volume of Y is on the x-axis is 24, 1, 2, 3, 4, when it is at 24, the highest temperature reached is 23. So I move up to 20 first of all. This is 20, then 23 is 1, 2, 3. There. Is it okay? Then when the volume is 28, this is 25, 26, 27, 28. Then on the y-axis temperature is 21. So I move up to 21. This is 28. This is 15. This is 20. Then 21 is there. Is it okay? Then when the volume is 32, this is 30. Look, this is 30. That one, 32. 32 on the volume or x-axis. Then the temperature on the y-axis is 19. So I move up to 19. This is 15, 16. This is 15 on this line. On that 32, 32. Then this is 16, 17, 18, 19. So 19 is there. Is it okay? So that is now about plotting. Is it okay, my student? Then after plotting, I have now to join using a ruler these plotted marks. Is it okay? So I have my ruler here. So this is what I'm expected to do. So I have to join this marks. Please just watch and see what am I going to do. So I have to ensure that I join these marks using a ruler, like this. Then I have to join them using a ruler like this, Is it okay, my student? And this is not a curve. Don't force to draw a curve. Is it okay? Then I have also to join these other 3 marks like this. Are you seeing, my student? So that's the shape of this graph. Are you seeing? So that's the shape of this graph. So I want now to move on and look at how to calculate the lowest temperature. First of all, we want to look at the lowest temperature. Let me write here. Lowest temperature of what? Of solution Y. The lowest temperature of solution Y from the graph. The lowest temperature of solution Y from the graph. So look here, my student. So the lowest temperature, you just look at this is now volume of solution Y. But now on the y-axis, this is where we have the temperature. So if you want to get the lowest temperature, you extrapolate or you extend this straight line until it touches the y-axis. Then you read the lowest temperature this side. Is it okay? So using a ruler, this is what you do. You continue extrapolating like this. Using dotted line. Is it okay? Then you read now the lowest temperature reached on this y-axis. So if this is 15, this 16, 17, now it is what? The lowest temperature of solution Y was 18.0 degrees Celsius. So this is 18.0 degrees Celsius. Also, from this graph, you are expected to find, from the graph, you find the highest temperature reached of solution Y. Is it okay? So the lowest temperature, we extrapolate on this side. Then to get now the highest temperature of solution Y used, I also extrapolate on this side. Is it okay? So this is how you do it. My student. Just watch and see. So you extrapolate this way. Using dotted line like that. Is it okay? Then you also come and extrapolate this other straight line like this. Are you seeing, my students? So you extrapolate the 2 lines, this one and this one, so that now to get the highest temperature reached, you now come and read from this point, like this. Now you extrapolate towards this, using a dotted line like this, towards the y-axis. You get it? Towards the y-axis like this. Then you read. Then the highest temperature means, now if this is 24, if this is 20, this 20, this 21, 22, 23, 24. So the highest temperature is what? 24 degrees Celsius. So the highest temperature of solution Y is 24.0 degrees Celsius. Is it okay, my student? Then, how do you get the volume of solution Y that completely neutralized? Look, how do you get the volume of solution Y that neutralizes solution Z? That's the base. So you look at where there is the highest temperature. When you extrapolate the two straight lines, where they meet, you now extrapolate it downward like this. You extrapolate it downward like this. You extrapolate it downward like this. Then you read the volume of solution Y that completely neutralizes the base, solution Z. Then this, if this is 20, this is 21, 22. So the volume of Y that neutralizes, volume of Y that neutralizes Z completely is 22 centimeter cube. Is it okay, my student? Let us now proceed and complete the other questions. After getting this one, we can now successfully answer these questions. So my student, without wasting time, we have plotted the graph. Then the question is, determine the volume of solution Y that reacted completely with solution Z. That means the volume of Y required to neutralize completely solution Z. We have calculated from the graph, isn't it? And we have found that it is equal to 22. Let me write properly. 22 centimeter cube. When you go back to that graph, the way I've been doing it, you will see that we have got that one as 22. Then question C. From the graph, determine the initial temperature of solution 1. In the initial temperature of solution 1. From the graph, determine the initial temperature of solution 1. So initial temperature is that temperature I call the lowest temperature of solution Y. When we extrapolated to the y-axis, we have found out it is 18. It is 18.0 degrees Celsius. It is 18.0 degrees Celsius. We have done it. The lowest temperature or the initial temperature of solution 1 is 18.0 degrees Celsius. Then question D. Determine the temperature change when solution Z is completely reacted with solution 1. Determine the temperature change when solution Z is completely reacted with solution 1. So here we take the initial temperature of solution 1, or the initial temperature or the lowest temperature. Then we also consider the highest temperature, and then we get the difference in between by taking the highest temperature reached minus the initial temperature of solution Y or the lowest temperature of solution Y. So in this case, the highest temperature from the graph, the way we have extrapolated, we have found out that the highest temperature, which is here, I have already written here, is 24. So the highest temperature, is 24 minus the lowest, which is 18, or the initial temperature. Then when you subtract this one, now my student, now the calculator now here is very important. So I have to take, that is 24 minus 18. This one gives me 6 degrees Celsius. 6 degrees Celsius. You get 6 degrees Celsius. Is it okay, my student? 6 degrees Celsius. Is it okay? So, the other question is, determine the heat evolved when the reaction is complete. Then you have been given specific heat capacity of this solution is 4.2 joules per gram per Kelvin. Then the density of the solution is 1 gram per centimeter cube. So my student, to calculate the heat of the reaction, we have a formula, and you know this, isn't it? This is just to confirm. As we do it, we are just confirming the basic knowledge you already have in class. Is it okay? Is it too dark? Is the board visible? Okay, thank you. So we have this formula which says that enthalpy, heat of a reaction, that is the enthalpy change, is given by mass of the solution times specific heat capacity times change in temperature, isn't it? And what is the mass? What's the mass of the solution? The mass of the solution, we normally take the total volume of the two solutions. We take what? Total volume of the two solutions. Which solutions? Remember, the volume of solution, determine the volume of solution Y that reacted completely with solution Z. So the volume of solution Y that reacted completely was 22 centimeter cube. Then from the procedure, the volume of solution Z, initially in the second procedure, I measured 20 mils. So you take the volume of solution Y plus the volume of solution Z. Is it okay? So here M, total volume is given by 22 plus 20. This one is the volume for Z, then this one is the volume for Y, which gives us a total volume of, that is 42 centimeter cube. Are you getting? Then we have this formula which says that density is equal to mass all over volume. So how do we get mass? We want to change this volume 42 centimeter cube to what? To mass. 42 centimeter cube to mass. So I apply this formula. Then I say that mass, therefore, is equal to what? Density times volume. Is it okay? Then, if that is the case, then how can I get the mass? Density of a solution is 1 gram. So to get my mass is equal to 1 times volume is 42. And this one gives me what? 42 grams. Is it okay, my student? Then finally, enthalpy change or heat of a reaction is given by mass times specific heat capacity times change in temperature. What is our mass? 42 grams. What is our specific heat capacity? Specific heat capacity is 4.2 joules per kilogram, joules per gram per Kelvin, joules per gram per Kelvin, which is for 4.2 times change in temperature. That's the change in temperature is here. Which is 6 degrees Celsius, which is same as 6 Kelvin. Is it okay? So times 6. So when you times those one using a calculator, my student, let us see. That is 42 times 4.2 times 6. That is 1058.4 joules. 1058.4 joules. Is it okay, my student? So that is now the heat of a reaction when the acid and the base react. So my student, let us move to the last question. And as I finish, my student, this is the last question. So the last question reads, determine the heat of reaction per mole. The question is heat of reaction per mole. of solution Y used. Of solution Y used. So my student, this one is very simple. And many students sometimes don't do well in such questions. Why? Because of lack of patience. Are you getting? So do you remember we have this formula which says that number of moles is equal to molarity times, that is times, let me write it properly. Molarity is equal to number of moles times 1000 all over volume. Molarity is equal to number of moles times 1000 all over volume. So to get now the number of moles, I make the number of moles the subject of the formula, where now I get molarity times volume all over 1000. So that's how you get now the number of moles. But in this case, we are determining the heat of reaction per mole of solution Y. And remember, solution Y is an acid. Are you getting? Solution Y is an acid. Is it okay? So in this case, we ask ourselves, how do we calculate the number of moles? How do we calculate the number of moles of solution Y? Is it okay? So, do we know the molarity of solution Y? Yes. Molarity of solution Y is 1 mole. The volume of solution Y, we calculated the volume of solution Y. In this case, it was 22 centimeter cube. So it is 22. Then we divide by 1000. So let me now see using my calculator. That is 1 times 22 divided by 1000. This one gives me 0.022 moles. Then these are the moles of solution Y. Is it okay? Then the question is demanding that we determine the heat of a reaction per mole of solution Y. So we ask ourselves this question. If these moles 0.022 moles are giving us this heat of reaction that we have calculated here. Just focus on this heat of reaction, which is now 1058.4 joules. What about one more? What about 1 mole? 1 mole will give us which heat? Which is very simple. So this is about now cross multiplication. Is it okay? So this same as 1058.4 divided by 0.022 moles times 1. This one gives me what? Let me see. 1058.4 divided by 0.022 moles times 1. This one gives me 49.09 joules per mole. 48,000 and 109.095 joules per mole. And remember, because in this case the temperature was rising, so this reaction is exothermic. So I need to indicate here a negative sign to show that this reaction was exothermic. So the molar enthalpy sign negative means the reaction was exothermic. So my student, just focus me on in just 1 minute. So whatever we have done today is very important, and as you prepare for exams, just go through this question again and again and do many more questions on the same, so that my student, you have enough capacity, or you have enough skills now to handle any question of the same. Is it okay? Until next time, I'm Mr. KW, a teacher of chemistry. Goodbye until next time.